We are going to learn about real numbers. And a real number essentially is any number that you can plot on a number line. And there are two categories of real numbers, rational and irrational. A rational number is any number that can be written as a ratio of two integers. If you do not know what an integer is, please look at the previous video on natural numbers, whole numbers, and integers. An example of a rational number is 7. 7 is a rational number because it can be written as a ratio of 7/1, where 7 and 1 are integers, or 14/2, where 14 and 2 are integers, or 21/3, where 21 and 3 are integers. And you can do so on and so forth. -5 is a rational number because it can be written as a ratio of -5/1, where -5 and 1 are integers, 5/-1, where 5 and -1 are integers, and so on and so forth. A square root that can be simplified is a rational number. Square root of 16, which equals 4, is a rational number. Square root of 100, which equals 10, is a rational number. Square root of 121, which is 11, is a rational number. These are just some of the many examples. Also, any decimal that is finite. Finite means that it comes to an end. Any decimal that is finite is a rational number. Some examples are 0.4, which can be rewritten as 4/10 or 2/5, where 4, 10, 2, and 5 are integers. 0.8, 0.001, 4.5, -8.9, 1.5, and 1.5 can be shown in a ratio of 3/2. All of these are rational numbers as well. Also, repeated decimals are rational numbers. For example, 0.33333 is commonly represented with a bar on top of the 3. That is a rational number because it can be rewritten as 1/3. Also, 0.66666, which is commonly represented as 0.6 with the bar on top, is a rational number, which can be rewritten as 2/3. 0.080808 is a rational number because it can be rewritten as 8/99. So if you notice, all of these numbers that I noted can be shown on the number line. So, for example, 0.33333 can be shown on the number line, which is basically 1/3. So 1/3 can also be shown on the number line. The square root of 16, which equals 4, that can be shown on the number line as well. 0.8, for example, can be shown on the number line. -8.9 can also be shown on the number line. All of these numbers that I wrote here can be shown on the number line. Now let's look at irrational numbers. Irrational numbers are numbers that cannot be written as a ratio of two integers. An example is the square root of 12. Another example is pi, which is approximately 3.1415, and so on. There's more digits to pi. You can't write the square root of 12 as a ratio of two integers, and you can't write pi as a ratio of two integers. If you notice, the square root of 12 and pi, which are two of many examples of irrational numbers, can be plotted on the number line. Square root of 12 is approximately 3.4641, and there's more digits to add for that, but that can be shown on the number line. And pi, which is 3.1415, and there's more digits after that, that number can be plotted on the number line as well. So remember that rational and irrational numbers are categories of real numbers. You might ask, well, so are all numbers real numbers? Can't all numbers be plotted on a number line? And the answer is no. Not all numbers are real numbers. To find out why, please look at the next video about imaginary numbers.